Hello, so in this video I just want to bring this whole method of undetermined coefficients to a close really, just by coming up with a summary of all of the different methods that we've looked at in the previous kind of few videos. So if you remember, we've got, the first things first, if you want to find a general solution to a non-homogeneous equation, so this is the non-homogeneous second order linear differential equation, okay, so in other words the right hand side is not equal to 0. First of all, you solve when the right hand side is 0. So in other words, first you solve when the right hand side is 0, okay, and you come up with a complementary solution. Okay, then what you do is you try and solve, you kind of come up with a particular solution. You try and come up with a particular solution based on this right hand side. So you look at this right hand side for kind of a clue, an indication of a function that you might like to try. A function that you might like to try, which then when you plug into here, so you basically try and generalize this right hand side as much as you possibly can. That's all effectively it is. Generalize this right hand side because of course that right hand side will be related to what goes inside this function. What this function is equal to, and then therefore you can form your general solution to your non-homogeneous solution just by doing the complementary solution, so the solution to the homogeneous case, plus your particular solution, so the solution you just guessed. Okay, and so in this video I just want to kind of go through all the summary of all the guesses which you can make. So first things first is if this right hand side is a polynomial. Okay, so if the right hand side, if your q of t effectively is a polynomial, so what do I say by that? It might be, for example, 4t squared plus 3t plus 6, or it might be, say, 7t plus 5, or it might be 67t to the 3039 plus 6. Yeah, it could be any one of these. It's all polynomials. Okay, and effectively what you do is you look at the highest power, and you say, right, there's a quadratic or a cubic or whatever it is, or a polynomial of order 3039. Okay, then you come up with the general formula for that. Okay, so for example, the general form for a quadratic of a quadratic is a t squared plus bt plus c. Okay, the general form of this thing would be at plus b. Yeah, the general form of this thing, I'm not obviously going to write it out, but it'd be at to the 3039 plus, and keep on going right the way through to bt squared plus ct plus d. Okay, so basically, all these terms in here will just be decreasing powers effectively. So basically, the idea is then you just try the polynomial form. Okay, you try the polynomial form. So I'm just going to get rid of that because that's a bit superfluous. But basically, you just try the polynomial form, and that will be your particular solution. That'll be your particular solution. Okay, so the next case which you can have is if you've got an exponential. So in other words, something like if you've got an exponential on the right hand side. So in other words, something like 3e to the 6t, 3e to the 6t, or 14e to the 5t, and so on and so on and so on. So if you've got that case, then you just try again the general case. And effectively, what you do is you just ignore what's in front of the exponential, okay, and you just take that exponential and just stick a constant in front of it. So that'll be the general form, okay. So it would just be, in this case, the particular solution will be a e to the 6t, or the particular solution here would be a e to the 5t. So in other words, you keep the powers the same. You keep the powers the same as they are over here. So this power is the same as that power, okay. So in other words, if you have e to the rt, then the particular solution that you'll try is a e to the rt. Okay, so that's basically the particular solution that you'll try. Right. Okay, so that's if it's exponential. Then what if the case if it's sine or cos? Well, if it's sine, let's say sine or cos, sine or cosine. Okay. Well, basically all you do now is, say for example, if you have like 6 sine of 3t, or 7 cos of 5t, or even if you had a combination of the two, so say for example sine of 6 sine of 3t plus 7 cos of 5t, for example. Okay, so you have a combination of the two. Then what you would try is you try the same thing in every single case. The particular solution you'll try is some constant times cosine of what's inside the brackets. So cosine in this case of this is cosine of 5t. If you want to write it sine first, actually, because that's how I've been writing it so far. So sine of 3t, it doesn't matter because you're adding them, what order you add them in. So that's 3t plus some constant times cosine of 5t. Okay, so in general, if this is just k, There's a k in here. Okay, and likewise this is k in here, and this is another k in here. Okay, then basically you would try. Oh yeah, they have to be the same. Then you basically try kt. Oops. And kt. Yeah. So what I just wrote down there was technically wrong because they have to be the same argument in both cases. Okay, so I wouldn't have been able to work out what I had before. They had to be sort of, because the 5 and 3 were different. I think it was 5 and 3, but basically they have to be either both 5 or either over both 3. But that's kind of the general form. It's very unlikely you get something like that in the exam, but it's good practice all the same. So that's the sine and cosine case, and then the exponential, then the product case is just going to be a combination of all of those different forms. Okay, so just multiply them all together, and just bear in mind that a constant times a constant must equal a constant. Okay, so number times a number equals another number, so it's not going to equal anything else. So you can use that fact to kind of make simplifications. So for example, if you multiply it out and you end up with c times e, so if you let one of your constants equals c and one of your constants equals e, and when you multiply everything out you'll end up with c times e a lot, then you can just make a new substitution. So you say, well, actually that's just going to be some constant. Okay, so you can use that so you don't have to find as many constants effectively. But hopefully that makes it a little bit clearer.